Okay, this is the lesson for Tuesday 1:30, and it is for 5.3 part 2. And so we'll get started. Here's the problem that we're going to work on. This is number 3, and it is cotangent x cosine squared x equals 2 cotangent x. So I'll give you a moment to write that one down, and then we'll look at that. So a couple things that are happening here. One thing, you notice that there's cosine and cotangent. So at first I might think, oh, maybe I want to substitute something, but then I'll notice that there's cotangents on both sides. So I'm going to get one side equal to 0, and then the cotangents, I'll move the 2 cotangent x to the left, and then I'll see if I can simplify it somehow. So I'm going to leave this cotangent x cosine squared x, and then I'm going to bring that over to here, and I'm going to say that is minus 2 cotangent x equals 0. Notice anything? Is there a common factor? Cotangent x is a common factor, so we'll go cotangent x, we'll factor that out, and then we have cosine squared x minus 2, and it's still equal to 0. So now we have 2 factors that multiply to be 0, and when we have that, we can set each of those factors equal to 0 and then solve those independently. So cotangent x equals 0 is 1, and so think about when the cotangent is equal to 0. Do you agree that if the cotangent is equal to 0, that's 1 over the tangent, so the tangent's undefined? Does that make sense? So the tangent is undefined, so when you flip it upside down, then the 0 will be up on the top. So that happens when the tangent of x is undefined. And so I'll put my little axis on here. All students take calculus. We just go from 0 to pi because tangent has a period of pi. And then we want to think about when is the tangent undefined, and that is at really a point that we might put on that axis that is 0, 1. And so tangent is sine over cosine, which would be 1 over 0. So cotangent is cosine over sine, so 0 over 1. And so the point there, our reference angle, is pi over 2. So the tangent is undefined, then cotangent would be 0. And since tangent has a period of pi, we just will have that recur every pi after that. So our solution for that one is x equals pi over 2 plus pi n, because the period of cotangent is because the period of cotangent is same thing, pi. And then our other factor is cosine squared x minus 2 equals 0. And so then we just get that cosine squared x alone. So that's equal to 2. And then the cosine of x equals plus or minus the square root of 2. What's this? Think about what the square root of 2 is as a decimal. It's about what? 1.414. Do you remember that? It's about 1.414. Is that, so it's about 1.414 or negative 1.414. Is that an issue at all? And that is an issue, because remember, we're trying to find the angle, but if cosine is going to be 1.414, the maximum and minimums are positive and negative 1. So our range for this is from negative 1 to 1, and so there is no solution for that situation in this equation. So that can happen as well, that there's just no solution as we look at that. Otherwise, we could have, you know, factored and things could have worked out a little differently for us. And so the solution to this one overall is just that part that's right there. Then our next thing is equations of quadratic type. And so we can solve quadratic equations, and you will have to be using whatever strategy you have to factor quadratics that you have in your list of things to do. So I have this slide just to go through many quadratic equations, ax squared plus bx plus c equals 0. So if we have 2 sine squared x minus sine x minus 1, that can be factored into 2 sine x plus 1 and sine x minus 1. When you refoil that out, you'll get 2 sine squared x. The outside will be minus 2 sine x and then plus 1 sine x, so we'll get that middle term of minus sine, and then the minus 1 at the end. So we can, you know, try to factor things. This one, if you look at it, doesn't factor at all, I think, because secant squared x would be secant times secant, so the first terms have to be secant. To multiply to get -2, you have to have a 2 and a 1, but since it's a -2, one has to be positive and one has to be negative, so you can't get a -3. Do you agree? So if I have -2, that would give me, and plus 1, that would give me -1 secant x in the middle term. And if I have plus 2 and -1, it would give me plus 1. So this would have worked if that were plus 2, I think, because then they could both be -1 and -2 to get the middle term of -3. And if not, you can still use the quadratic formula, because bottom line here is you want to get, if you are using those factors, you want to get those factors and set them equal to 0 and then find what the sign is equal to. And if it is not possible to do that, then you can use the quadratic formula and find kind of the missing values. And then again, we talked yesterday about, is it in the interval from 0 to 2 pi, or is it for all real numbers? Like that last one didn't say anything, so that was in the interval of all real numbers. And this one is in the interval from 0 to 2 pi. And so just any solutions within one rotation around those 4 quadrants. So here's this one, 2 sine squared x minus sine x minus 1 equals 0. And we'll say over the interval from 0 to 2 pi. And we talked about the fact that we're not including the 2 pi because we're including the 0, and so we wouldn't do more than that. Now, for factoring, and when it has a 2 out there, you just have to have your strategy. You know, if you use the box, if you use the distributive property, whatever you use. In this one, I'm going to use the guess and check because my only factors of 2 are 2 and 1. My only factors of 1 are 1. So I can write all my numbers in and then kind of figure out my signs. So to get 2 sine squared, I'm going to take 2 sine x and times sine x, and that'll give me 2 sine squared x. And to get the 1 in the back, I'm going to have 1 and 1. And since I want the middle term to be minus sine x, I want my 2 to be negative, and that'll be the outside terms. And so I'm going to put my negative there and my positive there. And then I'll just kind of double check it. First terms, 2 sine squared x, so that's good to go. Outside minus 2 sine x, inside plus 1 sine x, that gives me a middle term of minus sine x. And then last terms, negative 1 as I do that. So then I get two nice little factors, and I can set them equal to 0, and I can use my table of values. I already feel like they're going to work out super great. So the first one's 2 sine x plus 1 equals 0. Plus 1 equals 0. So the sine of x is going to equal what when I solve for positive or negative 1/2? Negative 1/2. So the sine of x is negative 1/2. And then this is like a way long time ago problem. We just kind of do our little all students take calculus. We ask ourselves, where is sine going to be negative? And so it's positive there, it's positive there. So our two angles are going to be in the third and fourth quadrant. If the sine of x is 1/2, what is the reference angle? Pi over 6. And so our reference angle is pi over 6. So that's the little angle that's going to be in those locations. So I'm going to take pi plus pi over 6, and so one of my angles is going to be 7 pi over 6, so that was 6 pi over 6 right there, and then I'm adding one more, and then my second angle is going to be from there all the way to there, and so I'm going to take 2 pi minus pi over 6, which is going to be 12 pi over 6 minus 1, which is 11 pi over 6 for that other one. And since our interval was just from 0 to 2 pi, then those are just our only solutions for that little part. And I didn't write x equals. Let me go back and do that a second. So that gives us two solutions for that factor. Then we have this other factor, the sine of x minus 1 equals 0. So the sine of x equals positive 1. And that's going to be one of those quadrant angles. Or, well, it's on our table as well. Let me do the all students take calculus. When is the sine of x equal to 1? At what? At pi over 2. And so that's going to happen at pi over 2, which if you think of a point 0, 1, and the radius of that unit circle is also 1. And so our reference angle is pi over 2. Since it's positive 1, if we can't use the 1 that would be down there because that would be negative 1. And so that one is going to only give us an x value of pi over 2. And I am going to say this, occasionally you'll get repeated answers for the two factors. Does that make sense? You know, and then you just have to say, oh, they're repeated answers, so I don't have to list them out. And so if I wanted to just say what my answers are, and let's see, the book authors often like put them in numerical order. So I think that would be pi over 6, pi over 2, and then 11 pi over 6. You are not really ever required to put them in numerical order. That is not going to matter to us as we go through that. And our next problem is number 5. And so this one is going to have something that is a little unique. So I'm just going to slide up to the top of this. So did you notice that even though we had to factor, everything was in terms of sine, correct? And so that made it a little bit easier in that regard. So problem number 5, and I probably have to go forward a little bit here. Problem number 5 is different because what do you notice when we're writing it? it has sines and cosines. And so 2 sine squared x plus 3 cosine x minus 3 equals 0. So I want to be able to use the factoring technique if possible that I can. And so the thing that I want you to kind of recognize or notice is has sine squared in it. And what can I use to substitute in for sine squared that'll make it, can I use something that'll make it into all cosines? Or the other way around, yes. But I'm gonna just kind of have a little think box here and remind myself sine squared theta or x plus cosine squared x equals 1. And so if I get sine squared x alone, it's going to be 1 minus cosine squared x. So if I substitute that in for the sine, I'm going to have to do a little manipulating and distributive property and all that. But then I'll just have cosine squareds and cosines, and then I can try to factor it from that. So I will color code that for this little first part. So that's going to be 2 times, in parentheses, I'm replacing sine squared with 1 minus cosine squared x, and then plus 3 cosine x minus 3 equals 0. So now I do have to like distribute and kind of clean things up a little bit. So we'll just do that. So that's 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And I'm going to put the squared term first, negative 2 cosine squared x plus 3 cosine x. And then I have the 2 minus 3, so it'll be minus 1 equals 0. Do you like having a negative in the front? I personally do not. And so an easy remedy for that is multiply both sides by -1, and then 0 times -1 will just be 0. So I can rewrite this as 2 cosine squared x minus 3 cosine x plus 1 equals 0. And same thing for this one, you know, to me, guess and check is just the way to go because 2 cosine squared is only going to be 2 times 1, and 1 is only going to be 1 times 1. So I am just going to write my factors. This is going to be a lot like that other one that we just did. So I'm going to have 2 cosine x and cosine x. That will give me 2 cosine squared x. And then I'll just have 1 and 1. And what do I have to do for the signs to get the -3 in the middle? So I need this to be +1, so these are both positive or both negative. Well, since it's a negative in the middle, they have to both be negative. And then I'm going to write in yellow, but then I'll get rid of it. So then I'm going to FOIL it out. First terms gives me 2 cosine squared x. Outside terms gives me -2 cosine x. Inside terms gives me -1 cosine x. So that gives me the -3. And then a -1 times a -1 is +1. So it all factored well. And again, you know, you have to have your strategy for factoring, whatever works for you. We're good to go with that. And so then just like in the past, we've got 2 cosine x minus 1 equals 0. So cosine x equals 1/2. And I'm going to write this one at the same time. Cosine x minus 1 equals 0. So cosine x equals +1. And then except that I have a different reference angle, it's going to work out pretty similar to the last one. So here all students take calculus. Cosine is positive, so it could be in that first quadrant, or in this case, the fourth quadrant. What's the reference angle? Reference angle for the cosine equal to 1/2. pi over 3. And so the reference angle is pi over 3. So one of our answers is going to be pi over 3. I'm going to pause my own self, not the recording, because it just made me want to kind of look back up here. Does anybody know? Do you know why I'm looking up there? As I'm getting ready to start giving answers, I wanted to remind myself if I was doing this over the interval from 0 to 2 pi, or if I was doing it in general. I don't have any interval, and so my answer has to be given over the real numbers. So I'll just write myself a note over the real numbers. And so I am going to have those repetitive answers. So my first answer is x equals pi over 3 plus 2 pi n. My second answer has a reference angle here of pi over 3, but I have to go all the way around there. So this will be 6 pi over 3 minus pi over 3. So that'll be 5 pi over 3 plus 2 pi n. And we had talked about multiple angles yesterday, so that I'm really actually happy we did that because we will maybe have some problems like that today. And so that gives us that situation. Then over here, when cosine x equals 1 for this one, when is the cosine equal to 1? At 0. And so that point is 1, 0. And so our reference angle is equal to 0. And again, in this one, we can use that one, but if we tried to go on the other side of the x-axis, we would get -1. So x equals 0 plus 2 pi. So the way we write that is x equals, 2 pi n, my bad, 2 pi n. X equals 2 pi n. So we have 3 solutions here. So we say x equals pi over 3 plus 2 pi n, comma, 5 pi over 3 plus 2 pi n, and 2 pi n as our 3 possible answers. And that's because it's over the real numbers and not just in that interval. If it had just been in the interval from 0 to 2 pi, we would have just had these 3 answers, that, and that. So pi over 3, 0, or 0, pi over 3, and 5 pi over 3. But it didn't give us that over the interval option, and so we had to give all of those. So the next problem in this little set is if we have this situation, and I gave you a note for this. We're going to square both sides, so that's going to be what we do here, because we don't have a lot of strategies if I have a cosine and a plain sine. But if I have cosine squared and sine squared, I can replace one of them with 1 minus sine squared or 1 minus cosine squared. But it can introduce extraneous roots, and so you have to make sure you check your answer if you're squaring both sides. And we've experienced that when we've done, like, radical equations in previous work and things like that. And this time we're in that interval from 0 to 2 pi. So we want to find all the solutions. Cosine x plus 1 equals sine x over the interval from 0 to 2 pi. And so again, by squaring both sides, I'll get sine squareds and cosine squareds, and then I can replace them one for the other. You don't have to write it again, but I generally am going to write it again because so many people are gone. And this will be our last problem for the day. So that'll get us kind of up to the multiple angle problems for sure. And so when I multiply this out, I'm foiling or remembering how to square problems like this. And so it'll be cosine squared x plus, don't forget the middle term, so I'll have plus 1 cosine x plus 1 cosine x. So that'll be plus 2 cosine x and then plus 1 and equals sine squared x. And then because we have a plain cosine, we're going to change them all to cosines. So the substitution I'm going to make is sine squared x. I'm going to change into 1 minus cosine squared x. And so that's going to be my strategy. And I'm going to leave this, oops, but I am going to try to write in blue. And so cosine squared x plus 2 cosine x plus 1 equals, and then this is going to be 1 minus cosine squared x. And I thought about like subtracting that over at the same time, but now I'm going to do that. So when I subtract 1 from both sides, then they cancel out in both of them. I'm going to add cosine squared x. And so what that's going to give me is 2 cosine squared x plus 2 cosine x equals 0. And do you agree that's kind of pretty desirable, right? That's going to be pretty good. And by the way, can I do something with that 2 right away? I can just factor out the 2 and or just divide both sides by 2, and I can say because 0 divided by 2 is going to be 0, then the 2's divided by 2 will be 1. So this is cosine squared x plus cosine x equals 0. And what's my common factor? Cosine x. So then I get cosine x times, oops, times, and then this will be cosine x plus 1 equals 0. And then my two cases here are going to be that the cosine of x equals 0 and the cosine x plus 1 equals 0. So cosine x equals -1. When is the cosine of x equal to 0? Well, students take calculus. That's equal to 0 at pi over 2. And so right here, I have that point 0, 1. And so my reference angle is pi over 2. And I feel like I'm doing that interval, right? So I'm doing that interval from 0 to 2 pi. You're maybe noticing I pause at that moment when I'm kind of thinking about what's going to work there as I look at that. So my reference angle is pi over 2, and what I'm going to say is going to work is going to be x equals pi over 2. I'll have to check them in a minute here. But then for this one, when's the cosine? Oh, students take calculus. When's cosine equal to +1? At 0, and so we want it to be equal to -1, so we really want it over here, and that's when our point would be -1, 0, cosine comma sine, if you kind of are forgetting that. And so here x is equal to pi. And those are our two possible solutions. I want to go all the way to the very beginning, original problem to check. And that's cosine x plus 1 equals sine x. So I'm going to come down here and say it was cosine x plus 1 equals sine x. And I'm going to check my work. So my first check, cosine pi over 2 plus 1, is it equal to the sine of pi over 2? What's the cosine of pi over 2? 0. So I get 0 plus 1 is 1. What's the sine of pi over 2? 1. So that is equal, and it does check. So I'll circle that one because I'm like, oh, good. I figured out that one works. And then cosine pi plus 1, and I want to see how that relates to sine of pi. And since I have, my picture right here, I can just look at that and say, well, the cosine of pi is -1. Plus 1, and that's 0, and the sine of pi would be 0, so that's equal, and it works. And so both of those solutions are going to work as we go through that. And then I think we will just leave ourselves at functions involving multiple angles. And so we'll do that the next time.